All right, so I will begin with the slides. I think in order for this to be a better discussion, it will be good if you have the materials before the class begins so that you can also read the materials beforehand. So I will try to share my slides to all of the participants in the chat column. Yeah, I have sent the file. I believe that you should be receiving the file very soon in several seconds from now. So if you can open the file, it will be good if you can open the file so that you can really read and ask questions if you want to confirm something. Yeah. And the committee can also make sure whether you can access or download the file or not. If you have any problem, you can just mention it to me so we can try to solve this issue as soon as possible so that you can have the materials beforehand. Okay. So while waiting for it to be uploaded to the chat column, I will start sharing my screen. So perhaps the committee can remind me if after. Yeah, so I just received a notification that the file sent successfully to the operator. Can you download the file?
I can download the file by Yusuf.
All right, good. So I believe that if you can download the file, then everyone can download the file. So you can have a look at the file and we can discuss based on that. Yeah. So as mentioned by the moderator, I'm currently the staff at School of Life Sciences and Technology, but responsible for the bioengineering and graduate study program. So I'll be delivering discussion, I would say, rather than a lecture, valorization of biomass using a biorefinery concept. Some materials may be overlapping with what Professor Gill has delivered yesterday. So we just go through several slides, and then if you have any questions, yeah, please, I have emphasized this many times that I prefer this to be a discussion rather than a lecture, yeah, a conventional lecture, I would say. All right, so valorization, yeah, before we proceed to the discussion, yeah, we are talking about first valorization. Any one of you have ever heard of valorization? Any one of you want to share your knowledge or background on valorization? What do you understand by valorization? Yeah, any one of you, you can raise your hand. Yeah.
Assalamu alaikum.
Yeah, Waalaikumsalam warahmatullahi. Yes. Yeah.
Good morning, sir. I'm working on the valorization of the PET into activity carbon.
Yeah. So can you define valorization?
It's a process of, burning in a oxygen-free atmosphere where you convert the material into activated carbon rather than ash.
I mean, the general definition. So if there's no burning, it is not valorization?
I don't know. I cannot comment on this, sir.
All right. Yeah. Okay. So basically, you work on valorization of PET, and it involves burning of the materials to convert to produce certain compounds that you want. All right. Yeah.
Yes, sir.
All right. Okay. Thank you. Any others? Any other participants? I would rather call you participants rather than students, yeah, so that all of us are participants playing different roles. Yeah. Any of the participants want to share their thoughts on valorization? So we have had, I think it's Firdaus before. Any other participants want to share their thoughts about valorization? If there's no one want to volunteer, then I just call the name, yeah, just to check whether you are here or not as well. So Hansley Kurniawan. Hansley, are you here, Hansley?
Yes, sir.
All right, Hansley, how are you, Hansley?
I'm good.
All right. Are you from bioengineering or are you from abroad?
I'm from biology major.
All right, biology major. All right. Then have you ever heard of valorization?
Actually, no, sir. It's my first time.
All
Uh,
right. So your first time. If you have to say few words about valorization, what would it be?
um, a research probably.
All right. A research. A research about?
Um, Maybe recycling food waste or
All right,
some sort.
recycling of food waste. All right, thank you. Very good, Hensley. It's a very good answer. Thank you, Hensley. Before I show to you the definition by ACS publication, any one of you ask the times? 3, 2, 1. All right. So
Yes.
all right. Yeah, I'm very glad. Please.
Yeah, I would like to just from my perspective.
Yeah.
I think that valorization is when we increase the value of a certain waste.
All right. Increase the value of a certain waste. All right.
Yeah.
All right. And so you are from?
Malaysia.
I'm Malaysia. All right. So have you worked with this valorization?
I'm working on damaged brain into products.
All right. All right. Very good. Okay. And your name is?
Nurul Ain.
All right. Thank you, Nurul Ain. So Nurul Ain has a very good point that increase the value of a certain waste. Yeah. It's very good. Yeah. But the issue is, does it has to be waste? Yeah? Or it can be other than waste. Yeah. So the definition by ACS publication, valorization is the transformation of byproducts, yeah, to alternative fuels, energy, and other useful chemicals with specific attention for sustainability and environmental objectives. Yeah. In a way, what Nurul I mentioned, that to increase the value is very good enough, yeah, but it doesn't have to be waste. It can be, is that terminology. You can call it waste, you can call it byproducts, you can call it co-products, you can call it also bioresources. Yeah. So anything that you do, yeah, by certain processes, biological processes, chemical processes, physical processes, any processes that can increase the value, yeah, of that bioresources, you can consider it as a valorization. And we have to mention, yeah, we have to highlight that the main objective of valorization is how can we focus on sustainability and environmental objectives. It's not true that you increase the value, you increase the money value of that bioresources, but then you are deteriorating the environment, you're polluting the environment. No. So valorization is increasing the value of certain bioresources with specific attention for sustainability and environmental objectives. And that brings us to the essential core of this course is biorefinery. And when we are talking about biorefinery, yeah, is an analog to oil refinery. Everybody, all of you should be familiar with refinery. Oil refinery, you have gasoline, you have all many petrochemical products coming out derived from this petrochemical industry. It is oil refinery. Now we are replacing, for the past 10 years, yeah, we are replacing the conventional oil refinery with biomass resources, with biological resources. So we call it as biorefinery. We are going to discuss it further. So we are talking about petrochemical, it's much easier for you. We are talking about industry. Yeah? So we are talking about industry, we are talking about economy. Yeah? So if we are talking about economy conventionally for the petrochemical products, now we are talking about circular economy when we are talking about bioeconomy. So what is circular economy? Some of you might have heard before. Some of you might be the first time to hear about circular economy. So we're going to discuss on that. But before we discuss more into detail about biorefinery and circular economy, I would like to show you a video about biorefinery. This is not my video. This is a video taken by, no, not taken, prepared by Wageningen University at the Netherlands, one of the institutions that is focusing on biorefinery. It would be good if you can have this view of biorefinery and circular economy from the Wageningen. So I'll be start sharing my screen. So to the community, perhaps to Pak Firman, you may help me if you cannot listen to the voice of the video. All right, so I'll be start sharing the screen and the sound, and I would like to confirm whether you can get the sound or not. Yeah, so can you watch the screen now? Is it
Yes.
visible?
Yes. The sound is very clear.
All right, so the video is 3 minutes. I enjoy the video.
We are not going to replace everything. We are going to do things in a different way, in a better way.
A bio-based economy uses renewable raw materials instead of fossil resources.
I think moving towards a bio-based economy and biorefinery is going to be the real big revolution of our future.
Wageningen UR facilitates and accelerates the transition towards this sustainable future economy, which will deploy radically different production methods. Existing and new components for products will be made by a new type of factory. Living plants.
The way we make use of our raw materials and energy is not sustainable in the long term. So we are looking for a new balance where we can use our raw materials and energy efficiently and still create value.
At Wageningen UR, we explore the potential of nature to improve the quality of life. Today, most crops are used for food and feed. This means that the plant biomass is not used to its full potential.
What we are doing in here is that the plant is composed by different components, and each of the components will be used for a certain processing. So we improve each of the components for your process that you are interested in. There are, for example, fields of miscanthus. It's one of the bio-based crops that is a very high yielding crop. It can produce a lot of biomass with good quality.
At Wageningen UR, we develop specific crops that are suitable for biorefining. Using the power of nature, we create the plants of the future. The chemicals, materials, energy, and food and feed.
Biomass is available from very different sources, in the form of trees, grass, but also waste streams. Biorefinery is important because unless you take the different components out of biomass, you cannot set them in again as raw materials for a different application.
For different applications in the market, there you need a really more or less pure product. So you have to be sure that you separate these components from each other.
Wageningen UR covers a whole range of expertise related to the bio-based economy, expertise on sustainable biomass improvement and production, on bio-based chemistry, on knowledge of food and feed chains, and on economic models.
When I think about 10 or 20 years down the line, then of course I think all the materials we're going to use will be very much based on a circular economy, and a lot of that on a biorefinery. I think really we'll see an important revolution that touches everybody's life quite soon, sooner than most people will expect.
Every day, we work with Dutch and global companies, governments and other research institutes. We innovate and develop new technologies in order to fulfill our mission, exploring the potential of nature to improve the quality of life.
All right, so that's around 3 minutes video. Anybody want to comment on that video? What have you heard? What have you watched? What can you take? Or the important message from the video? Anyone?
I think, sir, as they are...
sorry, your name is?
Firdaus.
Firdaus from?
From Kashmir, India.
All right, Kashmir. All right, okay. So,
as they are propagating the idea of biomass. I'm talking to a lot of people. Still a challenge for the industry, for people to shift from the fossil fuels to the biofuels. As I mean, if you see, I've seen recently there are electric tuk-tuk in our society, but they aren't so popular because they cannot move through the rough terrains and all these things. So still the biomass commercialization it doesn't go straight away. It's still following a blended economy where you have fossil fuel as well as your biofuels. And then the problem is again for countries like India, Pakistan, many people sleep here hungry. So there is always food versus fuel controversy in the biomass. There are a lot of, challenge. It's a good initiative right now to focus on, the biofuel because as the message is propagated that fossil fuels will finish soon, but how far is it sustainable? Um, I still don't. I have a still question mark on it because if you look at heavy vehicles which use jet fuels or whatever rocket fuels, there are very stringent requirements. So, will the biofuels will be able to fulfill those demands? Um, it will take time, sir.
All right, thank you for those. Yeah, I think for someone who is working on this biomass, you know the challenges. Yeah, it's not an easy process. Yeah, there are lots of issues that need to be taken into account to make sure that it achieves the initial objective that valorization is about sustainability and environmental impacts. Yeah. All right. Thank you for those. Anyone else who want to comment on the video? Any message that you think is very powerful that really touch your heart, or anything that you can take home message from the video? Uh, Anyone? No? If there's anyone, then I will call the name of Desiree de Costa. Are you here? All right, Desiree de Costa? No? All right, maybe she's having issues with the connections. We will proceed to who else will be lucky. All right, Desiree is outside right now, so it's okay. Yeah. I would choose Aliani. Aliani, are you here, Aliani? Aliani Kali. No, Aliani is also not here or currently outside as well. All right, Aliani is not active. Next is Aryo Dimas Pamungkas. Also not available. Next is Haikal. Haikal, are you here? All right, Haikal is also not here, so there will be remarks on your on your attendance. Okay, next. So those names are not responding, so there will be a Karima reduction on your score. Okay, so your attendance. Yeah. Next is Audrey.
Yusuf, sorry to interrupt you.
Yeah.
There are 3 students that raised their hands. think they want to ask question or perhaps.
All right. Okay. Thank you. But then I will hi Carl first because I call his name. No, hi Carl is not around. All right.
Sorry, sir.
Yeah. 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 So you want to say something?
I'm sorry. Can you repeat the question?
The video. Can you comment on the video?
I think there are many I'm sorry.
Yeah.
The video tell us about how biorefinery and bioeconomic concept can be some, how do you say it, be the terobosan, because there are research on the plant that used to biofuel and biorefinery itself. I'm sorry, I'm still terbata-bata.
It's okay. Okay. Thank you, Michael. So basically, you're saying that this the video shows breakthrough of this biomass, yeah, to produce bioproducts. Right. Thank you. And then next we have Sumayat. Yes, Sumayat, are you here, Sumayat?
Yes, I'm here.
Yeah, you're from, and Sumayat, you're from?
I'm from Comoros, but I'm studying in Malaysia.
All right. Okay. Okay. You want to comment on the video?
For me, it was from the I'm studying in biochemical biotechnology engineering, and from my integrated design, we learned that actually, like if we take, for example, one raw material and we produce, for example, in our IDP, it was to produce ethanol. We face some challenges in terms of how to transform the waste from this process, because it's sure that to transform those waste require a large amount of money compared to the process itself. So I wanted to know if you can give me some input related to that.
All right, Sumaya, thank you. But we can discuss on that later because we are currently discussing on the video, yeah? The video that I was showing. So we are trying to really get the same perception about the video that we were watching together before. Your question, don't forget to ask me again after we have finished the discussion, okay? All right? I'll get back to you later. Eunice,
Hello, good morning.
good morning,
So
Eunice.
I'm Eunice. I'm from the Philippines. I just want to share my insights regarding the video. So for me, it highlighted the use of biomass as a bio-based fuel in attaining sustainability. But we all know that it remains a challenge for every country, just like the Philippines. It calls for an urgent implementation because it is undeniably clear that fossil is quite limited, and we don't actually know how long can the humankind utilize it. That's all po.
All right. Salamat po. Okay, thank you, Eunice. It's very good that what you mentioned, that how can we valorize the biomass, but then you are aware of the challenges, right? Yes, thank you for this participants who have shared your thoughts. So basically, what you mentioned, what the participants mentioned is correct. But I just want to highlight that several very, very important messages from the video. Yeah? How we can explore the potential of nature to improve the quality of life. Yeah? So we can see lots of potential in our environments, in our surroundings. Right? If you look, you go up from your house, there are many plants, There are many bioresources, so it is our responsibility from the academics, from the industry, how we can explore the potential of nature. And the objective is to improve the quality of life. What we are doing right now, at the end, is how we can live better in this world for ourselves and our future generation. That's number one. Yeah? And then the second one is how we can use the power of nature to create the plant of the future. It's also very important. We know the main source of energy is not fossil. The main source of energy, if you look at every book that you have, is the sun. The sun is the primary source of energy. But do you know how many percent that we harvest the energy from the sun? It's very, 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 very small. It's less than 2%. So we can see here.
I wanted to have one question here regarding the sun.
Yeah.
You know, do you think it's rather a good idea to use the energy of the sun directly rather than to first convert it into biomass and then use the biomass, valorize the biomass? So it seems to me indirect, because in this process you lose the efficiency. If we have some kind of a mechanism like we are using the solar energy, I seen one airport in India, is Kochi airport, is fully run on solar energy. They don't use any kind of electrical supply from outside. So a model of this kind, which will use directly the energy of the sun, to like fuel cells we have, where we split, where we have the combination of hydrogen and oxygen to produce water. And in the end, I saw one train in Germany, it's running on the hydrogen fuel. So it's all clean fuel. So what problem here we have the biomass, and then we have to valorize it, and then I convert it into catalyst, and then I use it to produce biodiesel from palm PFAD, palm fatty acid distillate. In itself costs there's a lot of input of energy, and is it really a efficient process? Or because it costs energy, money, and then the question mark of reducing the cost or making it available in the market is still a challenge, as all the students said.
Yeah, you have the point. Yeah, it's about efficiency. But if I ask you, if we don't have the sun, so you're talking about whether it's much better for us to use directly, harness that
exactly
in terms of solar cell, and then we use in terms of electricity and everything. That's number one. It's very important. I think it's very efficient. Yes, we need that, but we also need different types of energy. Can we survive?
Sure, because that's part of circular economy. Yeah, I agree.
Yeah. Can we survive without biochemical energy? So can you answer that? Can we survive without biochemical energy?
The biochemical energy, when you talk about the biochemical energy, which type of biochemical energy are you talking? Yeah. Are you talking about the biofuels? Are you talking about the biochemical reactions that are taking place in our bodies from the centuries ago, since our origin? Are you talking about the biochemical processes that are taking place when we put the material for decomposition? What kind of biochemical reactions are you talking?
All of them. Yeah. So we have different types of energy. But for example, if you take one example, we are talking about the plants. The plants cannot survive without the sun. So the plants is converting the solar energy to biochemical energy, and then we need the plants to produce lots of foods, and the animals, everybody. All living organisms.
You know what is happening, sir? I tell you, sorry to say, I saw one video of Indonesia where they are just changing the biota and converting into a palm. They are converting into a palm farm for commercialization, because they think that it gives us the palm biofuels and all these palm fuel, which has a lot of demand, and then it affects the environment also. So either we need to look out for something which will not affect our forest cover of the whole planet. Look at the forest cover, like from the last 100 years or 1,000 years, it has been reduced a lot on this planet. So there I have a third sense, a fifth sense, that the people might be stealing, doing a lot of fraud in the name of biofuels by converting the forests or the farms into these palm plants, and then it will have a big disaster on the climate of the planet. What do you think on this danger?
Yeah, it's there's always exploitation, and there's always exploitation in everything, not only the plants. In internet there are many exploitation, but focusing on how we are discussing on the concepts first, and then we are discussing exploitation. It happens in everywhere. not only in the name of biofuel, in the internet, in business and everything. Exploitation happens everywhere. Yeah? But what I wanted to say here is that we need the sun, and then it can be harnessed in terms of solar energy. But then one root that is very important for mankind as well, and it's essential. It happens since the very beginning of the universe, is that how plants harness the solar energy to create a biochemical energy. And then from the plants, and then we eat the food, and then there are many issues about the food versus fuel. But then, how, for example, if we're taking the rice, but how many of the remaining components of the rice that we commonly throw away, not only rice, wheat and everything. So we are trying to look, if we are eating something and we are throwing away something. So this is that we are going to discuss. How can we minimize what we so-call the waste, or what we so-call as the byproduct. So that's very important. So to answer your question, yes, we need solar energy. We can immediately harness it, but we also have to be aware that something is happening since the beginning of the universe, that plants harness the solar energy to create biochemical energy. Then from that biochemical processes, we have fruits, we have so many things, and we're taking the fruits and then we're throwing away something. And that's where the valorization of biorefinery is taking place. Which one is more efficient? Of course, there are issues on that, and there are many exploitations. But let's not talk about the exploitation first. We are currently focusing on the concept, and then after the end of this, we can discuss on issues. Right now, we are focusing on the concept, and then by really understanding the concept, maybe you have good fundamentals of the concept, but the other students might not have the good concept yet. So let's focus on the concept of biorefinery, the classification, structure, and everything. Then we can discuss on the issues. Okay. So we will back again to the slides. Yeah. Natural resources, I'm not going to talk much about this. You know that there are many natural resources. There are non-renewable resources, and there are also renewable resources. And there are many issues about this. You have had and discussed in so many occasions. We have exploitation. That's what one of you were mentioning about exploitation. Yeah, but we also have to deal with excessive waste. Why we are not talking about the waste? Yeah, certain countries are facing terrible issues about this waste. How can we minimize the waste, and how we can valorize the waste? Yeah. And then we also have so many issues about the resource quality and how it can be threat to human survival. If you don't deal with these issues, we are threatening the survival of our next generation. We have energy crisis, yeah? We have our water crisis, yeah? We also have food crisis. Maybe in our country we have sufficient food, but we have to know that in other parts within our country or within other countries, there are people who are not having enough food. Yeah? When we have to deal with the issue that consumption is larger than production, we have limited arable land. There are so many issues that you might have discussed this in many other occasions. And this is just to show you again the global challenges that we are facing: food, water, energy, and everything. And you also have heard about resource recycling. Yeah? But then I just want to highlight about circular economy, the objective. Circular economy is related to economics, technology, system engineering, economic development, and environmental harmony. It's not just trading products. It's not just buying products or selling products. When you're talking about circular economy, you also talks about various components. Yeah? The technology, the system engineering, economic development, and also how it can be in harmony with the environment. The objective is to create a sustainable environment and how can protect the environment. There are 5 basic points: clean production, industrial ecology, sustainable agriculture, green consumption, and waste disposal. As for the cycles, we have internal cycles, cycle between production, post-recycle cycle, energy and material cycles. And there are 3 important principles: reduction, reuse, and recycling. So we have heard about resource recycling, but I just want to highlight that maybe you have not really focused or are aware that there are 5 basic points, and then there are 4 cycles that need to be considered when we are talking about resource recycling. Yeah. Next is Biorefinery. As we mentioned before, that some of you also have learned that Biorefinery is a wide range of processes coupled for the production of bio-based product from different biomass stocks. As I mentioned, that is analog to the oil refinery. There are four important keywords when you're talking about biorefinery, right? So it's a very big plant. Yeah, we have inputs and then we have products, or we call it output as well. So the issues are the key points that we have to optimize, yeah, the use of resources, the inputs here, yeah, what the potential, the alternative for the inputs. We have to optimize the use of resources, and then we also have to minimize the waste, yeah, what we so call the waste or byproduct, and then we also have to maximize the benefits and profitability. And all of this is to create a sustainable development. So that's the objective of biorefinery. There are many issues, yes. It is very challenging, yes. It's a high cost, yes. Yeah. But then here let's discuss about the concept first, and then after we have understand the concept, then we are trying to look what is happening in the industry at the moment and how the industry deal with this. Maybe what we know is not the same as what happening in the industry. Yeah. So again, let's focus on the concept, current application, then we can discuss relevant issues. Biorefinery engineering, we can, or bioproduct engineering, we can say, yeah, if you're talking about biorefinery, I will show you the textbooks as well. We have different aspects. We have biorefinery feedstock engineering, we have biorefinery process engineering, we have biorefinery product engineering, we have biorefinery process engineering. Again, we are discussing on the concept, yeah, rather than discussing on the issues. Yeah, we can discuss the issues later. Yes, it's very important. We're talking about biorefinery product engineering, and we're talking about bioenergy, bio-based chemicals, bio-based materials, food and animal feed in general. So you can choose. Yeah, it depends on the situation that you are facing. Yeah, what is the problem that you are facing? Then you can choose this route of product. And then we move to the circular economy, having given a broad overview about biorefinery, and then we know biorefinery is related to industry, and we are talking about industry, we have to talk about economy. Unlike linear economy that you might have familiar with, is take, make, dispose. We take something from the environment, we make the product, and then we dispose the waste. That's what we call as linear economy. But in circular economy, it is an industrial economy that promotes greater resource productivity, yeah, aiming to reduce waste, avoid pollution by design. Yeah, so you have to design the process. Circular economy doesn't happen without intention. Yeah, it has to be designed, and we have to take into account the material players. There are two material players. We have technical nutrients, and we have biological nutrients. So biological nutrients is designed to re-enter the biosphere safely. So it's not logic, it's not rational. If you take everything from the plant, then you take everything from the environment, not returning it back to the environment, then there will be a deficiency of nutrients in the environment. So some nutrients, what we call as biological nutrients, has to be given back to the sphere, but the important key was here is safely. Yeah, so you have to return back to the environment. It's not fair you take everything and not giving back. As a human being as well, when you take something, you need to give it back. All right, and then we also have technical nutrients. This is very important for our system. How you design to circulate at high quality in the production system without entering the biosphere, as well as being restorative and regenerative by design. Yeah? So you have technical nutrients that you maintain in your system, and you also have the biological nutrients that you, after certain processes, it can be given back to the environment safely. So this is circular economy. It's not just about selling products, but it is more than that. It's about productivity and designing the whole process, taking into account the technical nutrients and the biological nutrients. Yeah, these are the bioproducts. Some of you, most of you, are aware of this, that this is the era of the bio-based products. Just to show you these diagrams, some of you might have seen this diagram, but some of you might have not seen this diagram. Depends on your background. Okay, But just to let you know that we are not talking about all biomass. That we have to take care about at the end what is the benefit that we can take from the biomass. In terms of that, we have to take into account the amount and also the value of the biomass. Yeah? So at the bottom part of this pyramid is the bioenergy, yeah, where we have the largest amounts of biomass and capital investment, but then we have very low product value as compared, for example, at the top of the pyramid is the biomaterial that requires less amount of biomass and capital investment, but it produces the highest product value. So then we have biochemicals, we have engineered products and everything. Biofuel is here. Bioenergy is in general. Solar energy is types of bioenergy. Biofuel is more specific to fuel. Yeah? So just to let you know that there are these pyramids, so you have to choose, yeah? Depending on the problems that you have, depending on the amount of money that you have here in the industry, what kind of products that you want to produce to solve a specific issues with limited amount of investment that we have. Yeah? So we have bioenergy, we have biofuels, we have conventional bioproducts. Yeah? These are the explanation. If you have questions, we can discuss about this later. So the main source of biomass. Yesterday, Professor Gill was talking about the source. One of the sources is lignocellulosic bioresources, lignocellulosic biomass, because Professor Gill has a point, because lignocellulosic bioresources is the most abundant resources on Earth. Yeah, that is available for us. But then there are also many issues about the lignocellulose. Yeah? So from biomass is basically everything that contains organic matter, so this is from carbon dioxide, but then it releases CO2, then it is zero carbon dioxide emissions. And the lignocellulose is the most abundant resources on Earth. That's why there are many research are focusing on lignocellulose. But then there are also a lot of issues. How can we deal with homogeneity and consistency of product when we are dealing with the lignocellulose? Now we move to the modus operandi. Yeah, we are talking about the biomass. Now, how we can process the biomass? It's the core of the biorefinery itself. We can use thermochemical processing, we can use mechanical processing, biochemical processing, and also chemical processing. This is just to show you in general. Yeah? It depends on the feedstocks and the end products, and also on the intermediates. Yeah? The type of biorefinery, it can be categorized into types of the conversion process, types of the raw material, types of the intermediates, and the types of technology implied. Yeah? So you can define or categorize biorefinery depends on the types. Yeah? This just maybe you are familiarized with this when we have, for example, starch crop. Yeah? These are the processes that you can do for the fractionation, and then we have the biological processing, and the end we have the product here. So in general, we have the upstream processing, and we also have the downstream processing. Yeah? This is a general concept of bio-based product from sustainable renewable feedstock, which can be categorized into upstream processes, which deals with the biomass and also preliminary treatments, and then we have the processes. And after the processes, we have the downstream processing for the separation and also purification to obtain the final product. Yeah, any questions so far? Yeah?
Sir, I would like to
Yeah.
discuss about the concept of circular economy, if I may.
Yes.
Yes. Specifically, maybe in the bio industry image, like circular economy, as we know it, is responsible production and consumption. Like it is promoted in the SDG number 12. And we do this considering the life cycle of the product. Like we see here, it's a circular cycle, not a linear economy like the traditional one that we may use. And this here, we the tangent aspect with biorefinery is circular economy try to take as much value as possible from the biomass by responsibly consuming biomass and bioproduct production by using the biomass as much as possible and not producing so much waste as possible. And my question is regarding this process, how do we control the end life of the bioproducts? Maybe we could use the example of biomaterial. Like in the bioproduct segment, you show that the biomaterial is one of the highest value of bioproducts that use less biomass required. And uh, to ensure that the bioproducts is entering a circular economy, do we have to ensure that the biomaterial is compostable, biodegradable, or usable? Because if at the end of the day the biomaterial is not uh, able to degrade in the landfill, like maybe bioplastic from starch, even though it's bioplastic made from cassava or maybe like uh, potato, but if it still requires so much here to degrade, does it still considered as circular economy? Or maybe there is some other solution to that. Thank you, sir.
So your question is,
Sir, he is saying that if we have the biomass, when we are making a product out of it, and after that, when we have to send it back to the nature for decomposition process, if it takes a long time, then isn't itself this whole process futile, or is it like that, sir?
Mm, if I may, well,
yeah. You are
the
asking about the product life cycle, right? Is it?
yeah, the
When
point
it
of circular
stops?
economy is not only degradability; it's also reusability, like maybe the recycle, like
Berarti kita bikin jembatan ya? Yo, nambah lagi ya Rabe dong. Yo, ini
Maybe the community can mute the other participants and let Tadi finish his comments. Yeah, Azari, you may.
yes, sorry, I kind of forgot where I left off. The point of circular economy is not only compostability or biodegradability; it's also reusability or recyclability, like the concept we already know now. 3R: recycle, reuse, reduce, like that. But I still feel kind of confused about this because not all biomaterial is recyclable and not all of them is compostable, because all bio-based material is made from biomass, but not all of them is biodegradable. And that makes me question about the circular economy part of the product, because many startup and bio industry promotes their product by giving their name a circular economy concept production and also made from biomass, but I think it's not really appropriate to say that they are producing in circular economy concept if their product is still becoming a waste. I think maybe
Right,
yeah.
I got your points. Yeah, I think I got your points. Yeah, maybe to answer it, so you're basically focusing on circular economy. Yeah. So how can we say that this is circular economy? What is the boundary? Yeah, I think it's more important on that. What is the boundary, or what is the scope of, what is the criteria? Yeah, what is the limitation? Yeah, to say that this is circular economy. So to answer your question, so we have to draw lines. Yeah, we have to draw lines between circular economy or process, yeah, and the products. We have to draw lines. It cannot be without any boundaries. If we are talking about something, there are no anything that without boundaries. We have to create boundaries. So do you agree with me, Atari? There have to be boundaries in everything that we do. If there are no boundaries, then we are so confused where to end this. All right? Do you agree with me that we have to create boundaries?
Yes, I think that's true, sir.
Yeah. All right. So we have to create boundaries. Even when you are solving your mass energy balance, you have to create boundaries, even though it's not physically there. So we have to create boundaries so we can focus our discussion. Yeah? So when we're talking about circular economy, is that the most important thing about circular economy? Yeah, what is it? Yeah, there are several keywords. First, it's aiming on productivity, increasing the productivity, and you're designing the process. Designing the process in a way that you take into account technical nutrients and biological nutrients to produce the products. So as long as you and circular economy is focusing on aiming productivity and also the environment. So if in the process there are technical nutrients that you can use as much as possible without throwing it to the environment. Yeah. So by doing so, you are reducing the waste. Okay? And then we have these biological nutrients that you have to throw back, or you have to channel it back to the surface safely, so that the surface or the environment would have sufficient nutrient to proceed in the longer run. So that's, we have to draw the lines over there, regardless of the product that you are mentioning. So circular economy does not talk about the product, because you have to draw lines. You don't draw the lines. If you are not drawing the lines, then if you're looking at the products itself, then it's not going to be anywhere. It cannot stop. So when we are talking about circular economy, we are talking about economy where it increases the productivity of the process, where you have the technical nutrients in order to minimize the waste, and then you have to have the biological nutrients. Whether the products is entirely compostable or entirely recyclable and everything is a different story. It's about, we are talking about product life cycle over there. All right. So again, we have to draw lines. If we are talking about the circular economy, it's that the criteria to say that it's circular economy is how that it increase the productivity and paying attention to the environment by minimizing the waste, taking into account the technical nutrients, and whatever being released to the environment is ensured to be safe. That's the lines for the circular economy. We're not talking about what is the end of the product. Yeah. Okay, Azadi?
Okay, sir. I wholly agree about your answer. And by creating boundary, I think it's making us easier to think about it. I think it is true that as long as we try to minimize the product, I think the minimize the waste or byproduct. I think it's quite okay to say it's circular economy, because the product itself maybe will be used in a long time with the consumer. I think it's thank you, sir.
All right, okay, thank you, Teddy. So this are general remarks to all of you. Yeah? So if you are taking into account so many things all at once, it's become confusing. So let's solve things step by step, drawing lines, so that it's much easier to solve the issues here. All right, so let's get back to the slides. We are talking about, so can you see my slide again now? No, I'm having problem with my slides. I have to discard this. Maybe, well, basically, actually, maybe the committee want to take pictures first, perhaps, before we proceed to the discussion. Actually, I haven't finished the content first because we have, yeah, I'm sorry to the committee, but I slightly changed the format because I rather prefer these interactive discussions. But I just want to confirm to the MC, do you, because it's already 10 o'clock, do you want to take the photo of the session now, or you want to wait until the end?
Let's take now, sir.
Firman? All right. All right, the committee is some way busy, so let's just continue first until the committee is ready. So anytime when you're ready, the MC and the operator, when you want take pictures, you can just interrupt and we can do what you want us to do, right? So in the meantime, we can proceed with the discussion. Yeah? Talking about the process just now, and then yeah, we stop here, and yeah, we have this lignocellulosic biomass. I'm not going to discuss this because Professor Gill has given a very thorough discussion about this lignocellulose. Yeah? But why? Is because lignocellulose is the most abundant resources on Earth right now. Yeah. Apart from the lignocellulose biorefinery, we have the syngas. Yeah, we have the syngas platform biorefinery. Yeah, we have the syngas. Yeah, syngas mainly consists of carbon monoxide and hydrogen. Yeah? How we can use fermentation. Yeah, and then we have this marine biorefinery. Yeah, maybe some of you are working with marine resources. Yeah? But it consists near about 71% of water. Yeah? 79% is seawater. So it's a very huge amount of potential. Yeah? And then we also, for example, we consider alga, which is drawing a lot of attentions, but also a lot of issues about this microalgae. Yeah? Most important issues is that high cost and also productivity. So lots of issues are trying to solve on the strain, yeah, to do genetic engineering to create strains that can has the ability to produce the desired compounds at higher productivity, and then how we can valorize the processes so that we have various bioproducts with certain values and at the end can lower the cost. Yeah? So this is just an example, the microalgae biomass, we have the extraction process, and we have the solid, we have the lipid, which these phases can have different processes, and then you have different final products. Eh? This is just concepts, yeah? And then we can later I will show you companies that have done this in real. Yeah? We have also here this oleochemical biorefinery. Yeah? So these are producing oleochemical products. Yeah? We have the green biorefinery. Is primarily subject to chemical, physical, or biological treatment to separate liquid fraction and solid fraction. Yeah? This process, silage grass is preferred as raw material. That's why it is named as green biorefinery. And we have here what we call as the whole crop biorefinery. Yeah? For example, is cereals, including wheat, rye, maize, and critical are generally used as raw materials in the whole crop biorefinery. Again, this is to show you that we have different types of biorefinery. If perhaps before this you know it's biorefinery, that you have this optimization, you're minimizing waste, you are maximizing the benefits, but then what types of biorefinery? Now you know that we have whole crop biorefinery, we have marine biorefinery, we have a green biorefinery, the different types of biorefinery. You don't have to do everything, but you just choose what is more suitable depending on your issues. Alright, now I'm showing you the biorefinery industries. Commercial biorefineries that are currently existing and running on Earth at this particular moment. Yeah? Of course, maybe this is not all of them. These are just examples. Perhaps I would also like to hear the input from you from different countries I've heard, like from India and from Philippines, from Malaysia. So what kind of companies that you can see that all they label themselves as a biorefinery company? What we have here is, for example, is that there is categorized as a biorefinery companies, is for example, is Nestio from Finland. It produces high quality oil product from waste and residues. We also have Abingua Bioenergy in Spain. It raw material procurement. It also produces bioethanol and sugar. We have the RAC from the US. It produces biodiesel and lower carbon intensity products from biomass. We have the UOP Honeywell company in the US that produce petrochemical, biodegradable detergent, unleaded gas, and etc. from the bioresources. Not only that, these are the top four having high capital. We also have British Sugar in the UK that produce sugar, bioethanol, and animal feed from biomass, from grass, as the name is from the grass, producing protein from the grass, and then we have Sinopec from China producing biofuel from waste oil. So these are just examples that yes, we are talking about preliminary experiments or fundamental research. There are many issues, no doubt. I'm doing research about this as well, and there are many issues about that. But then there are certain processes that are well established. There are certain processes that are much easier and then are more efficient, and these companies have shown that it's possible. But does it perfect? No. Yeah? There are always issues that need to be improved. But then to show you that biorefinery is not just a concept, it's not just a theoretical, it is doable. But yes, there are many issues about the efficiency that you might be focusing on, and about the cost. If it is not efficient, then we're talking about the cost. We can discuss about that after this. We also have available bioenergy, for example, that if you're talking about food versus fuel, so we have different generation, for example. So the next generation that, for example, in the European Union, in my colleague from the Dutch Mountain Trading Company later will explain it. In the Europe, for example, that for the past 20 years they are focusing on the renewable energy, but now the current direction say that the renewable energy cannot be produced from food resources. So now before this they are producing from sunflower, from rapeseed, from food sources. But now the legislation has outlined that the source of this biofuel cannot be from food source. It has to be from non-food sources or what we consider as waste. So my friend from the Netherlands just came here, then they are currently seeking to use rubber seed, for example. And not only that, we are currently working on this to make sure do we have enough rubber seeds? Because all the processes to produce biodiesel from biomass are established. Then we can switch the input. And now they are looking at rubber seed, for example, because Indonesia has the largest rubber tree plantation on earth, although the latex productivity is quite low as compared to Thailand and Malaysia, for example. And then in doing so, we also have Japanese company that is also interested to produce biodiesel from rubber seed, for example. And these companies are already commercialized. So my point is that if you're talking about food versus fuel, it is very important. So now many companies, especially in the Europe, they have outlined that the renewable energy, particularly biofuel, cannot be derived from food sources. It has to be from non-food sources. For example, that's and the current issue that we have this Japanese company coming to Indonesia, we have Dutch companies coming to Indonesia. That's the case of Indonesia. Perhaps in Thailand and Philippines and India is different. I also maybe want to tell your stories on that. So Avilo, for example, they use forest residues, milk residues, crop residues, music crops to produce different products and having different market segments. This is Avilo energy. All right, next is the principle of sustainable biorefinery. Perhaps before we discuss about these principles, anybody want to ask questions or discuss on something? No? If there is no question, I should remember from somewhat. After this, we can go to your questions. If there are no questions from the other students or sorry, the other participants. I just want to highlight this because this is very important. Which companies we consider as biorefinery companies? Those companies that are in accordance with the IEA Bioenergy Task 42. What does it say? Is that sustainable handling of biomass into a spectrum of viable products energy is known as biorefining. This is what has been outlined by the IEA Bioenergy Task 42. It has to be sustainable handling. So yes, there are lots of issues, but if you're talking about biorefining, at the end, you're talking about sustainable processes. Principle number one, a biorefinery system should establish the maximum economic welfare of the society by by reducing the utilization of energy reservoir, biomass feedstock, and the cost that is involved in supply chain performance. Yeah? A biorefinery system should assure minimal environmental influence, yeah? By reducing the utilization of non-renewable energy reservoir, yeah, and generation of dangerous waste. So that's why when we're talking about biorefinery process, we try as much as possible, try to use renewable energy in the process where we can generate the energy from the material within the processes itself. Yeah, so we try to reduce this. Of course, we cannot entirely replace it, but we try to reduce it as much as possible. One, energy is a very important issue when you're talking about large scale production. So one way to reduce this energy is to create your own energy from the technical nutrients that you have within your system. Yeah, a biorefinery system should provide higher social welfare by upgrading public profiles, encouraging regional establishment and development. So, biorefinery is more than just processes. It's focusing on the economic welfare. It's focusing on the energy. It's focusing on the environmental influence. It's focusing on the social welfare as well. So these are the three principles of sustainable biorefinery. And then we also have this sustainable chain management that's the three principles. They have another four should fulfill the market needs. Yeah, should not conflict with food supply again. So we would not have this food versus food if we really apply this biorefinery principle. Should have economical biomass to product supply chain. So it's no use you're producing products that at the end you're not or not able to compete with the supply chain. Yeah? Should have good conversion productivity. Yeah. So these, of course, these are principles. Yeah, you can achieve this or not. That's various issues that need to be discussed. Yeah. But then just to let you know that biorefinery is guiding us to a better environment. Is it 100% realizable? No. Well, there are many issues. Of course, some of you have mentioned some of the issues, and there are many other issues. All right. So type of biorefinery, we are trying to look at different perspectives, and then this biorefining in a circular economy. So that's why in the beginning we are discussing this as together. We are not talking about biorefinery and circular economy separately. We have to discuss this together, and this is as outlined by task 42 that biorefining in a circular economy. Yeah, identifying the most promising bio-based products. Yeah, so that's why you look at the pyramid whether you want to produce bioenergy, biofuel, biochemicals, bioproducts require different amount of biomass, capital investment, and the values of the products. You decide based on the issues in your location and then also the investment that you have. Yeah? To be co-produced with bioenergy, yeah? To optimize overall process economics and minimize the environmental impact. Yeah? So as I mentioned before, that energy is very crucial in a production system, and we are trying to reduce as much as possible energy from the outside by producing your own energy within the system to reduce the cost and also to ensure the stability of the entire process. Yeah, that's. I think I've almost finished here. There are many slides in here, but I think we are not able to discuss everything. Yeah, I prefer that we discuss more on what you find is relevant and what is the problem that you're dealing with. Yeah, but just to show you that there are several issues about biofuel and biorefinery. Yeah, these microalgae are very interesting to show here that because it is also related with your economic assessment. Yeah, your collaborative project that you have to do about preliminary economic assessment is I want to show you that this what we have for the microalgae. Uh, we can go through all these processes. Yeah? What I wanted to highlight here is that a value addition of microalgal biomass per 1,000 kilo in a biorefinery. Yeah? So we can see that the microalgae can produce lots of products, and then these are having different chunks of this pie. Yeah? So you can see we have food proteins, we have feed proteins, we have sugar, phycoremediation of nitrogen, oxygen, chemicals, and biofuels. And you can see here that how we have to pay attention with the different chunks that are having high values, and biofuels is not the highest. Yeah? So the current issues with valorization of algae is the cost. So we are not able to produce only one product, but to produce several products to really cut the cost by having income from different products. So this is to show you a comparison of energy estimates for microalgal-based biodiesel. Yeah? The different processes, you can see the energy from biodiesel. Energy from biodiesel in waste treatment. Energy from biodiesel wastewater treatment and anaerobic digestion. So you can see here that how that different processes will require different energy, and then the economic analysis. Let's briefly read this together because it's very important. To give you highlights whether this is visible or not. Numerous studies on the thermoeconomic and life cycle assessment of microalgal biodiesel production are available. The production of microalgal biomass using the current available technologies costs approximately $5 per kilogram, which is unacceptably high for biodiesel production. The main issue is high cost. The challenges lie in high biomass production costs and unfavorable energetic balance at a significant process. So what to do? On the other hand, various high-value products sourced from microalgae are already commercialized. The biomass production cost of $5 per kilogram is more than acceptable if such products are also derived. So we're not producing only biodiesel, but we're also producing high-value products. According to some estimates, may command a price as high $123 per kilogram biomass, the value of the product. It is expected that with process modifications and engineering advancement, the biomass production cost can be brought down to as low as $0.5 per kilogram. From $5 to $0.5 per kilogram. Moreover, coupling phycoremediation of pollution loads in waste streams to microalgal biomass production offers economic up to $170 per ton biomass product and environmental gains 90% in reduction in water footprint. So you can read this article in complete, but then to highlight that issues that valorization of biomass is the cost. So you cannot only produce one product, you have to produce different products within the system using the technical nutrients to have the co-product credits. Now, maybe some of you are familiar with the co-product credits here, but then for bioengineering students, for example, that's what we learned in your final year. So the main point here is that biorefinery is helping to reduce the production cost. One aspect of biorefinery is to maximize the benefits, to increase the benefits of the product by having different products that are having higher values. If you are interested to look more on the literature, you can read this book, Biorefinery Production Technologies for Chemicals and Energy, and also we have specifically in cellulose biorefinery engineering principles and applications. These are just two examples. There are many other books and literatures available about biorefinery. So just to show you several works that we have done during ITD, that we try to apply the concept of biorefinery to different sources. We work with richly stressed thermal, with the paddy, with the rubber, with the coffee. We also work with the red solidify and also with the orange. That's what some of the works that we have done. And these are just some of the examples, the process flow diagrams of the biomass that we use. For example, this shows for the citronella, where we can produce citronella oil, we can produce different products from citronella, yeah, plants, yeah, and then we have this, for example, for coffee, yeah, how we can increase the production of coffee by integrating with the stingers bees, and then by integrating the coffee plantation with the stingers bees, you produce not only coffee beans, yeah, but you also produce propolis, and also honey from this process. Right? These are just an example of how you can integrate processes so that you can have more technical nutrients available within the system, and then you can make use of the technical nutrients to produce as much products as possible. All right? Yeah, that's from me. So I'm giving back to the moderator.